In the vast savanna of data analysis, understanding the average is crucial. Just like a pride of lions gathering around a watering hole, data points often cluster around a central value. This central value, a single number representing the heart of a dataset, is called a measure of central tendency. Three main measures help us navigate this landscape: the mode, the median, and the mean. Each offers a unique perspective on the typical value within a dataset. These measures paint a picture of the typical value, allowing us to make sense of large amounts of data. The mode is the most frequent traveler in our data safari. It represents the value that appears most often in a data set. Imagine a watering hole frequented by zebras. If we count the stripes on each zebra and find that 10 stripes is the most common number, then 10 is the mode of our zebra stripe dataset. The mode is particularly useful when dealing with categorical data, like colors or animal species. For example, if we observe a herd of elephants and note that gray is the most common color, then gray is the mode of our elephant color data set. However, the mode isn't always the best measure of central tendency. In some cases, the mode might be far from the center of the data, especially if the data is skewed or has multiple peaks. Imagine a flock of flamingos, most of which are pink, but with a few outliers sporting brighter orange feathers. While pink would still be the mode, it wouldn't fully capture the presence of the orange flamingos. The median, our next explorer, represents the middle ground. To find the median, we first need to line up our data points in order, like a procession of ants carrying leaves. The median is the value that sits right in the middle of this ordered line. If we have an odd number of data points, the median is simply the middle value. For example, if we measure the length of 5 chameleon tongues and arrange them in order, the third tongue's length would be the median. However, if we have an even number of data points, the median is the average of the two middle values. Picture a pair of rhinoceroses locking horns in a playful battle. To find the median weight of these rhinoceroses, we would take the average of their two weights. The median is less affected by extreme values than the mean, making it a more robust measure in the presence of outliers. It's like a sturdy baobab tree standing firm amidst the shifting sands of data. Section 4. Diving into the mean. The mean, perhaps the most familiar explorer, is the mathematical average of our data points. To calculate the mean, we add up all the values in our data set and then divide by the total number of values. Think of a group of meerkats sharing a tasty scorpion. The mean weight of these meerkats would be the total weight of all the meerkats divided by the number of meerkats. The mean is sensitive to every single data point, meaning that extreme values can significantly influence its value. It's like a delicate spider web, easily swayed by the slightest breeze. For example, if we add a particularly heavy elephant to our group of giraffes, the mean height would increase significantly, even though most giraffes are still much shorter. This sensitivity to outliers makes the mean a less reliable measure when dealing with skewed data. Section 5. The impact of distribution shape. The shape of our data landscape influences which measure of central tendency is most appropriate. Imagine a symmetrical mountain range, its peaks mirroring each other. In a symmetrical distribution, the mean, median, and mode coincide at the peak. In a skewed distribution, the mean, median, and mode diverge. In a positively skewed distribution, the mean is pulled towards the tail. In a negatively skewed distribution, the mean is pulled towards the lower tail. Understanding the shape of our data is crucial for choosing the right measure. Section 6. Conclusion. Choosing the right measure. Each measure of central tendency offers a unique perspective on the average within a dataset. The mode highlights the most frequent value, the median represents the middle ground, and the mean provides the mathematical average. The choice of which measure to use depends on the nature of the data and the questions we seek to answer. Like a wise old tortoise, carefully considering each step, we must choose our measures wisely. By understanding the strengths and limitations of each measure, we can gain valuable insights into the hidden patterns and stories within our data. The journey through data analysis is full of wonder and discovery. By mastering the tools of central tendency, we can navigate this landscape with confidence, uncovering the secrets that lie hidden within the numbers.